So the last couple of days, we've been talking about zeros and equations. We've learned a lot about equations. What do you remember about what a zero is for an equation?
So I remember that we talked a lot about intercepts.
Okay.
So that when something was zero, it means it crossed like an axis, like maybe the x or the y axis.
Perfect. Perfect. So a zero, another name for zero, we talked about is x-intercept.
Okay.
So x-intercept is, what's an x-intercept?
It's just like when the graph cuts through the x-axis or
Perfect.
intersects it.
Perfect.
Yeah.
So it's either going to cross it like that, or it could just touch it.
Okay.
So that's kind of what we talked about the last couple of days. So we're going to apply that to a different theorem that we're going to learn today. So but before we do that, let's just kind of go over, let's just review a little bit what zeros are besides what we just did. Let's look at this equation that we have on the board. So if we have y equals x minus 3 squared, let's factor that out.
Okay.
Would you mind coming up and factoring it out for me?
Yeah. So if it's squared, that means I have two of them, right? So I'll have x minus 3 times another x minus 3. Do you want me to keep going past that?
Yeah, perfect.
Okay. So then I do FOIL. X squared minus 3x minus 3x plus 9, which then is x squared minus 6x plus 9.
Perfect. Thank you.
Yeah.
Thank you, Catherine. Okay. So we have y equals this. Now, what do you remember that we had to do in order to find what the zeros were? Do you remember how we found the zeros?
Well, we'd have to see what made the equation go to 0.
Yeah, so what do we have to change y to?
So y would have to be 0.
Y would have to be 0.
Yeah.
So we had to go 0 equals x minus 3 times x minus 3, which is what you did right here. You just replaced y, right? Okay, so if we have that 0 there,
Yeah.
if we have these equations, what's going to make it 0? What's going to make this whole thing 0?
One of these has to be 0.
Yeah.
Right?
So let's work with this one.
Okay.
What has to make that 0?
So 3. 3
3.
has to make that one 0.
Yeah. So if we have that equal, so what did we plug in for x, you said?
3.
X equals 3.
Okay.
So if that is our 0, then where should it cross the x-axis?
At 3, right?
At 3.
Yeah.
So here when we have 1, 2, 3,
And is that because y is 0 and x isn't?
yes.
Okay.
Perfect. Good memory on what we talked about the other day. So when y is 0, because we set it equal to 0, this x-axis right here, sorry, I should have labeled that for you. The x-axis, when we're on the x-axis at all, y equals 0,
Okay.
because this is 0. So when we hit anywhere here, y is 0, and we're either crossing or we're touching.
Okay.
Okay, do you remember that from the other day? Okay,
Yeah.
perfect. So the other thing that we talked about, and we're going to leave this up here because this is going to be helpful for later.
Okay.
The other thing that we talked about the other day was division. Do you remember doing long division with the equations? It was a little weird because we were used to just doing it with numbers, right?
Right.
So then we applied it to using equations.
Yeah.
Do you remember how we did that?
Mm-hmm.
Okay, so we did that yesterday. So we're not going to go over that a whole lot today.
Okay.
Remember that good?
Mm-hmm.
Okay. Okay, so now we're going to apply what we learned before with the finding the zeros and with the long division, and we're going to talk about the remainder theorem.
Okay.
So the remainder theorem, would anyone want to read that to me?
Yeah, I'll read it.
Read that for me.
For a polynomial p of x and a number a, the remainder on division by x minus a is p of a. So p of a equals 0 if and only if x minus a is a factor of p of x.
Whew, that was a lot.
That's a lot.
There's a lot of different notation in there that we really haven't talked a lot about. So let's go over the notation just so that we make sure that everyone understands what the notation is and the different symbols and different random things are. So let's just go over the first part. So it says for a polynomial p of x.
Okay.
What does p of x mean?
just an equation, is that
Perfect.
right?
So if we say p of x, we talked about this a little bit, but if we have p of x, then p of x is the equation and x is our input. That's what we're plugging into our equation. So we're just gonna go over this to kind of remind ourselves of what these mean, okay?
Okay.
So this is our original equation.
Mm-hmm.
And a number a.
Okay.
What does a represent?
Like 6 or 7 or 8.
Perfect. So a represents a number.
Okay.
Some number, we don't know what we could do at 6. We can do 3, 8, anything. Negative, let's make one of those negative. We'll do negative 6.
Sounds good.
So, number A, the remainder, what do you think the remainder goes with?
Division?
Division. Perfect. So that's our application of division. So when we do long division, and if we have that x minus a, so remember when we took an equation, when we took
Right.
like x minus 2, and we divided it into, let's say we did x squared plus 4x plus 1.
Mm-hmm.
If we divided that in, then our remainder, after we divide it all, is going to be what we get down here.
Right. Mm-hmm.
So, the remainder on division by x of a, which is right here, so this represents our x of a.
Okay.
Does everyone understand that?
Yeah.
Okay, so x of a is what we're dividing into our p of x, so this represents our p of x. The remainder, what we get, is called p of a. Now, remember over here how you told me that if we had x minus 3, that we'd get equal to 0.
Yeah.
Remember that? If we got x minus 3 equal to 0, then hit the x-axis.
Right.
Now, p of a, if we get our p of a, if all we have down here is 0, then we know that it's a factor. If it's 0, then it has to be a factor. So that means that this would factor into this equation. So if that factors in, then that tells us that this originally was a factor and that it made it equal to 0 and that it worked into this equation. So that kind of is a lot, right? So let's just do an example.
Okay.
Why don't we do this example right here?
Okay.
Catherine, would you mind coming up and doing this on the board
Yeah,
here?
for sure.
Okay.
So I want to do division right
Yeah.
here.
So we're just
Okay.
gonna do long division right here.
Okay. So I know that x goes into x squared just one time, or x amount of times.
Mhm.
Is that right? So I'll have x squared minus 2x. And I want to subtract. I'd have 0 and plus 6x. Or x minus 2x, yeah. And then I want to bring down this plus 1. And then I know that it's going to go into 6x 6 times. So then I'll have 6x
Good job.
minus 12. If I subtract that, those are going to go away, and I'm going to have 13 here,
Okay.
which is not 0.
Not 0. So what's our p of a?
So it's not a factor.
It's not a factor.
Right.
So p of
Okay.
a equals 13, and because it's not 0, it's not a factor.
Okay.
So it's not going to multiply anything out
Mm-hmm.
to give me the equation, the
So it's
original
not
equation.
super helpful.
Right,
Okay.
right.
Got it.
So now we're going to work on a worksheet, and Catherine is going to be 2 different students. When I am on that side, she is going to be Sean, and when she's on this side, she's going to be a student without disabilities. All right, students, so here's our worksheet that we're going to be doing for today. So after we just went over the remainder theorem, so we have our worksheet, and the remainder theorem, remember, is applying kind of what we just went over. So the things that we talked about with the long division, and when we talked about finding zeros and graphing them. So instead of, since we've talked about all these things with graphing and whatnot, here's your worksheet. So you're going to do each of these problems, and whatever we don't finish in class, we can do at home, or you can come in before and after school. And if you feel like you want any other materials, come and ask me. I have calculators out for you, and rulers and different things, so you can graph it by yourself, or you can graph them on a graphing calculator. Since we've worked a lot with graphing, I'm going to allow you guys and have you guys work with graphing calculators.
Okay, sounds good. I just realized I don't have a pencil.
Oh, let me get you a pencil. We have lots of extras of those too.
Okay, thank you.
You're welcome. Five minutes later. How's it coming over here, Catherine?
It's going good. I'm just trying to put this into here. So see if x minus 3 is a factor of x squared minus 6x plus 9.
Good job.
And I just want to make sure it goes into the very first number first, and then I go from there.
Yeah.
Okay.
How's graphing coming for them?
It's okay. So my x-axis is my zeros. Is that right?
Mm-hmm.
Okay. And then whatever if this is a factor and my remainder is 0, then that is the x-intercept. Is that right?
Mm-hmm. So we see what makes this equal to 0.
Okay.
And whatever made that equal to 0?
So in this case, it's going to be 3.
Perfect. So then
Okay.
it's going to cross where?
So it's going to touch at the x-axis.
Touch at the x-axis.
Okay.
Perfect. Good job,
Makes
Catherine.
sense. Thank
Good
you.
job. All right. How's it going, Sean?
It's going okay.
Yeah.
Yeah. So,
So I see you're doing really well with your worksheet.
yeah.
And so how are the Legos coming?
So I think that if I make them touch like I'm supposed to at where it was 0, that's the right way to do it. Is that right?
Perfect. So, so what are you making right there with the Legos?
So right here I'm making like the umbrella shaped graph that we've been doing. And I'm trying to make sure that it touches at 3, because that's where the 0 was on the worksheet.
Yeah,
Is that right?
that's perfect.
So I always know if that's the number that sends it to 0, that that's where it's supposed to touch.
Yeah.
Oh.
So how does that apply with the remainder theorem? If it touched 3, when we divided that in with the remainder theorem, what did we get for our P of A?
We got 0
0. Why did we get 0?
because A sends it to 0. Is that right?
Yeah,
Okay.
exactly. So like the theorem says, it says, so P of A equals 0 if and only if, and that's a pretty strong statement. That means if the first part's happening, then the second part has to happen no matter what.
Okay.
So
So if
P of
I
A equals
plug
0.
in A, then I should get 0 for my equation.
Perfect.
And A can be anything.
Yeah.
Any number.
Yeah.
Negative or positive.
Negative or positive. But if we plug it in, if we don't get 0, then we know
Then it
that
doesn't work.
right, and that wasn't a factor, right?
Mm-hmm.
Perfect.
Okay.
Good job.
Thank you.
All right, now 10 minutes later. Okay. All right, Catherine, would you mind coming up and showing me an example of number 2?
Yeah.
Actually, let's do number 3.
Number 3.
Okay, so why don't we work through number 3 that you did on your paper? So just go ahead and start working it out, and we'll all work together. Sean, why don't you let me know how she's doing over here with her equation, okay?
So here's my, oh, wrong one.
It's okay, you can do that one.
No, it's okay. We'll do the other one. That was my bad. Plus 3x squared plus 3x plus 1. And I want to see if x plus 2 is a factor.
Perfect.
So this is where I want to do my division.
Yep.
Is that right? Okay.
Now before we do it, if
Yeah.
if it is a factor, what are we going to get at the end?
We should get 0.
We should get 0.
Okay.
Okay, let's check it.
So I have x squared,
Good job.
x cubed plus 2x squared. So when I subtract these, I just get an x squared. So that should go into 3x squared, 3x times. Am I putting stuff in the wrong spot? Yeah, I am.
Nice catch. Where did you catch that?
Okay. X squared, this will go in 3x times. Yeah. So I should have 3x squared. Hold on.
So what did we do there?
It wants to go in only
That's okay.
one time because I'm doing this one.
Yep, good job.
Okay, so then I have x squared plus 2x. Okay.